1969, Santa Barbara, California. Our country faced the worst man-made ecological disaster it had ever faced. Men, women, children, Americans answered the call for help. 2010, the worst man-made ecological disaster this world has ever faced. Months later, with wildlife devastated, beaches closed, industries destroyed, there are still no solutions. We stand around wondering why someone has not solved the problem. In 1969, we the people made the difference. We the people had a voice. We the people made a choice to help. Welcome to the ORU, Oil Recovery Unit. These devices are a unique mix of old-school technology successfully used in the '69 Santa Barbara oil spill and 21st century design, replacing rowboats with barges, pitchforks with aqua conveyors, and landfill waste with oil extraction equipment. The ORU can remove crude oil from the surface of water rapidly and without the use of chemicals, distillates, or particulates. It deploys a biodegradable and readily available organic absorption medium and then recovers the oil to be transferred to a refinery. Let's take a closer look at the process utilized by the ORU. This process starts with the wheat and grain harvest of the Midwest. Many thousands of acres of wheat straw are cultivated back into the ground once the grain is harvested. Using standard hay baling equipment, these fields can now be harvested for wheat straw and shipped via rail car to the Gulf Coast, where the 800-pound round bales are put to a rebaler and processed into easier-to-handle 50-pound square bales, although they were actually rectangular in shape. Each round bale equates to approximately 15 square bales. These square bales are palletized and staged, awaiting distribution by the ORU. The perpendicular conveyor, illustrated in orange, is able to be moved the full length of the forward ORU arm. This enables the crew to load the hay onto the spreader feeding system with minimal effort. The accumulator, represented by the red equipment, packages the straw into 3x5 packs of 15 bales. These are moved onto an automated feeding system for the forward spreaders. Using this automated system, shown in green, the forward spreader operator can independently control his feed and distribution, providing up to 45 bales staged in the feeding system. The hay is blown on the oil surface from both sides of the ORU. The centrally located hydraulically controlled agitator forces the straw through the oil. Using the natural buoyancy of the straw, the oil is lifted from the surface of the water and attached to the straw. Recycled hay is blown onto the oil surface from the rear of the agitator, ensuring maximum absorption. These blowers are shown as yellow tubes with downward-facing nozzles. A partially submerged central conveyor hay lift is used to lift the oil-saturated straw from the surface of the water. The hay is then transported up into the core of the ORU. At the heart of the ORU lies the patented oil press. This unit, based on 150-year-old technology, utilizes today's latest advancements in manufacturing. Hydraulic motors and direct gear drive reduce maintenance and failure points. The mix of organic absorption material and raw crude is fed into the top-loading hopper. Hopper agitators keep the mix from settling into the bottom of the press. 15 linear feet of steel presses extract the oil from the straw. The straw is deposited onto a removal conveyor, while the crude is pulled through the bottom by an auger into a sludge pump for transfer into the onboard storage tanks. This stored crude is eventually removed for transport to refining station. Once processed through the presses, the hay is then moved along conveyors where percentage is recycled using a vacuum and redistributed into the oil aft of the agitator. Any hay not siphoned off by the secondary blowers passes onto the onboard kiln for disposal. The command bridge is located at the center of the ORU for maximum visibility from bow to stern, overseeing the spreading, agitation, mixing, extraction, and eventual disposal processes. The ORU uses technology and solutions developed over the past century, but implements them with 2010 technology. This process and implementation of these technologies is what makes the ORU both unique and valuable. It is simple, environmentally friendly, and the only consumables are renewable products of a grain harvest. A patent has been filed for this process and the utilization of the technology systems within the ORU. There are 3 versions of the ORU available. Designed as a harbor and beach patrol, the ORU Light leaves the docks loaded with 10,000 bales of hay. Over the next 24 hours, the ORU collects approximately 6,000 barrels of oil before exhausting its onboard supply and returning to offload the gathered crude and reload with hay. The ORU LH is a long-haul version designed for extended trips. Carrying 20,000 bales of hay and 30,000-gallon tanks, the ORU LH can stay in the oil slick for extended retrieval operations. The 4 external hay barges can be separated and replenished from the docks, allowing the ORU LH to stay even longer in the slick. Lastly, the ORU EP, or extended platform, carries no onboard primary distribution systems and relies on smaller barges to distribute the absorption medium. This unit carries 3 full crews on board, and with the crude offloading facilities also on board, this unit can stay in the oil slick collecting crude indefinitely. Supplies are ferried to the ORU EP along with parts, fuel, and the new crew. Together, we can make a difference. For additional information, please contact Robert Hill, rhill@uab.edu. Again, that's Robert Hill, rhill@uab.edu, or info@oilrecoveryunit.com.